Problem of the week for this week. There are an even number of real numbers in a sequence, and two players will alternate turns removing a number from either end of the sequence with the goal of removing the numbers that have the greatest sum. The question is how the first player can guarantee that the numbers that the first player removes adds up to be at least as much as the numbers that the second player removes. So I have an example here. Say we start with these 6 numbers, 8, 1, 1, 7, 2, 9. It's an even number of numbers. And I'm going to have the first player and the second player both use what's called a greedy algorithm. The first player has to decide between an 8 or a 9. And the first player is just going to take the biggest one, picks the 9, right? So now we go down to 8, 1, 1, 7, 2. Player 2 is going to get greedy and say, I don't care about strategy at all. I'm just going to look at the option I have right in front of me, and I'm just going to pick the biggest one. So I pick 8, grabs an 8, down to 1, 1, 7, 2. Greedy algorithm. We just look at this choice, and player 1 says, 2's bigger than 1. I'm going to take the 2. Takes the 2. Greedy algorithm. Player 2 looks at these 2 and says, 7's bigger than 1. I'm going to take the 7 and be very happy about it. Takes 7, and then there's 1, 1. It doesn't matter which one they choose. They each choose 1, 1. And this is the result we have at the end. Player 1 gets a total of 12, and player 2 gets a total of 16. That is a failure. Player 1, the greedy algorithm failed in this instance. So the question is, what strategy will guarantee that player 1 will get at least a tie with player 2? First one who gives me a solution wins the prize.